So, in order to understand human complexity, language perspective, and then we have to know the individual learning, cultural transmission, our biological makeup, evolution. So these are the kind of thing that we have to deal with. And that's the reason Professor William Wang and we built up a Center for Human Complexity in Central University, in Chinese University of Hong Kong, with Taiwan, with Peking University, and now we like to extend it to many places. That you have to look at the human behavior, human language from many, many different perspectives. So if we want to look at the human behavior, now we have a lot of data and we know about what's going on. We need to know the remote history. We need to know what is long time ago. Not only just yourself, but your species, your society. And then what all these stimulus that converge to some calculation platform, and then that give you certain ability to respond. So you can not only achieve a proximal goal, you actually fulfill a long, long distal in the future goal. So sometimes you have to say, well, I want to do this, but right now if I do it, it's not good, very good. You can have long terms of statistical calculation in your mind in order for your behavior to be successful for your life. Distal stimulus, distal response, and a goal-directed behaviors. Now you look at it. What is that platform? That platform is the brain. And that's the brain that we have that we begin to know a lot today. Okay, so if you look at it, the brain evolution about language, we have around 300,000 years ago, we have language began, then hunting, then cave painting that we saw, and then in that cave painting you can see two different kinds of calculations. Some is just depict, the other one is make a plan to say something metaphorically or something like that. And then writing began about 8,000 years ago, and then 4,000 years ago we begin to see the printing, storage, and duplication. And 2,000 years ago we begin to see the printing book, telecommunication, computers, automation, email, and nowadays www. We are now evolved into a different kind of species compared with the people down there. Now, this is an effect. We begin to talk about language, and we have an interesting thing to learn about language. So if I
ba 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 ba.
So you heard ba 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 ba. That's what we created. We asked the student to say ba 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 ba, and that's what you heard. But pretty soon, when you see the person in full, then you
ba 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 ba.
It's not ba, it's da. But actually in physical forms, exactly the same acoustically. The students still, the tape still ba 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 ba. But because of the mouth, it's impossible for you, don't stop, close your mouth and open it. It's impossible to have ba. So when you look at this, you say, that's okay, it's da da, it's ba ba ba. But it's,
ba,
you cannot hear ba anymore
ba,
if you look at it.
ba,
But if you take your eye away, close your eye, and then open it again,
ba.
then you can see it's in your mind. So it's kind of a verbal, biological knowledge that you have to learn to listen. And that's the reason that you need to have a brain that will take a lot of information, store the information. And in a long time ago, that's the brain and the cognitive behavior that we have, the so-called guru xue, that we map every place in the brain. And of course, it's the initial of mapping the brain. It's not that correct, but it's a beginning anyway. We have, at the beginning, we use animal models to look at the different parts of the brain, and then we have studied the patient when they get a stroke, and then later on, and then we see their behavior begin to change, verbal output, listening, they have some changes, and then we look at it. After they die, we look at their autopsy, and then where is the damage. Then we begin to map out behavioral language and where the damage is. So before 1990, brain and language, we use patient's data. That's what you see, where they are happening of their stroke. And so you have global aphasia, you have Broca's aphasia, focus on here, you have Wernicke, and you have conduction aphasia, that Broca is okay, Wernicke is okay, but the connection was broken. And then you have anatomia in the posterior. We infer brain ability in different areas based upon patient's data. Immediately you said, well, that's not very good, because patient, during this long time of suffering, their brain may reorganize in order to compensate. So what you see may be after the damage and not during the damage. So, but in any case, at a time, we do have a connective ability that people have different kinds of way of looking at the brain organization. But if you look at, it's in the left, language in general. So it's Bill told us in one of his lectures, and I put it down here, a real understanding language will not be achieved until we have a reasonable notion of its neurological mechanism. And so that's what we go in. We have basically frontal lobe, parietal lobe for perception, and then cerebellum. That's very important, but we don't know much about it yet. And then temporal lobe, that for more sensory input and output. Now, we also have the picture about brain surgery by Rembrandt. Broca, who had this dong after the patient have a stroke, and he had only ability to say dong, dong, dong. You ask him any question, dong, dong, dong. That's all he can do. So he took this brain and looked at it after he died, and he took the brain to the Society of Anthropological Society and said, look, human being speech in the left hemisphere. And that became a very important statement of the world, of history. And you can see that's where here, and you can see the Broca area. But this is a huge, modern days, we can look at it, Broca historical case with the MR imaging. And you can see it's actually extended in many different places, not just whole focus in many areas. And so the dong, dong, dong is a serious damage, not just that particular area. Anyway, that's what we know. Okay, just generally by 1990. Now, then we have encountered the so-called 一头两翅. We have one head, but we have two hemispheres. And then we begin to look at what happened. When you have epileptic, and then in too severe, the random discharge sometimes go from one hemisphere to the other. So the whole brain is really suffering. So we said, well, maybe we should remove the tumor and then cut the corpus callosum commission and then cut it. And so it won't spread to the other side. And by the time Professor Wilson has a lot of study on the cat in section the corpus callosum, so we knew on the surface they would not transfer to the other side. So if we do this, you have to cut it open. So information going from one hemisphere will not go to the other hemisphere. Then you begin to do an experiment that if, for example, you presented apple, and apple was presented here in the left visual field that will go to the right hemisphere. The right hemisphere cannot name apple. If you present these words down to this side, right visual field, go to left hemisphere, then he will say apple. So you can very clearly, some function has been kind of dissociated. Okay, but it's not to say that your right hemisphere doesn't know apple. You use the hand with the left hand, try to reach it. He can pick up the right object. So knowledge there, but he just cannot name it. So language restricted to the left hemisphere, getting very clear from this particular kind of experiment. So you can see corpus callosum, and then you can do a lot of things. And you can also begin to find something very interesting. I was in Dongbei, in Shenyang, and working on a study. And the patient was from a village. And this girl is a very beautiful girl, but suffering from this very serious epileptic disease. And so when she get into the problems, she will bite and she will do a lot of violence stuff. So they decided, well, maybe we should try this split brain research. So she was cut. After she recovered, there's a medical doctors just graduated from medical school from Peking Medical University at that time, and he came over as an intern, and he fell in love with this beautiful girl because she's really a nice girl. When she was no symptoms, she was very nice, very beautiful. He fell in love. And so we all said, gee, the girl said, no, I am a patient, and I sometimes have some trouble. I don't want to have anything with you. I will ruin your career, something like that. Very sympathetic. This boy is still quoting. So finally, this girl gave up. So one day, he asked, let's go to a movie. And the movie is outside. It's not just in a theater. The 板凳 the movie outside. And this girl said, okay, finally. So in the evening, before this boy show up, the doctor show up, young doctor show up, this girl was sitting on her bed. It's in a hospital. I was sitting there, going to her plastic closet, getting a very beautiful 衣服, and then wear on that, and sit down there. One hand. You see? You know, 我们那种衣服是有那种纽扣的, you know the kind of button is on that like this, right? And you have to use this to open it. Or you have to kind of knit it together with one hand. And she's sitting there, put on a very beautiful new dress, and then bottom up. It's right hand. This is left hand. Bottom it up. This is right hand. Taking it off. As if my right hemisphere with my left hand. Yes, yes, I let it go. Yes, yes, I let it go. But this one is, no, I shouldn't. I shouldn't. So he took it off. And then several times she suddenly burst into tears. And said, take it off. And so I don't want to go. And so another big break after that. And so decided, and then they transferred the medical doctor back to Beijing, and so on and so on. But anyway, you can see we call a split brain syndrome that was really clearly being shown. Right hemisphere is hoping for something. The left hemisphere is saying, no, we shouldn't do that. And then you can actually observe this in many of these split brain patients by testing them conflicting information. And you will see they try to make up story on top of this conflicting information and to make it why they should do things like that. Okay? But anyway, I won't get into that, just to show you that they have all this. And then we see we have a track. It's different from a chimpanzee. And so we are able to speak much more clear and distinguish more sounds from our speech. And many of the chimpanzees cannot do that. But anyway, the interesting thing is this. Because of this particular empty spot here inside, the cavity here, it's actually dangerous for young kids. So before 6 months or 8 months, the baby is actually on top. So that's fine. But after the 6 months and 8 months, the seed begins to descend, going down. So it leaves a hole there. So the mother all know that. You don't use your bottle, the milk, open it too big. If the then it's dangerous. It can go down. You don't use the little bowl that sugar coin that and they like to eat it. It's very dangerous. So there's a lot of mortality because of that. But it's important for our language anyway. After 12 months, your muscle is getting better control. You overcome these problems, then you're able to mimic the real world outside. So if we take this, you can see ba, pa. Ba, pa to our ear is very different. Ba, pa. However, for a young baby just born, the question is, can they differentiate out ba and pa? Because physically, they are very similar. Look at this. If you take a speech spectrum, what you see is the onset time, ba, and pa is only about this empty spot. It's a little bit late in terms of its vibration. And that's only 25 milliseconds or 20 to 25. In other words, our ear had to be very, very good at picking it up. That acoustic sound that's coming out, the vibration, is only 25 millisecond difference. But we clearly hear the difference, ba and pa. So young kids was born with a very important predisposed ability to discriminate. Subtle difference in terms of time. And now you can see we need a lot of young kids learn to look at other people's face and imitate. So you can see the imitation, even very clearly that we are doing this. And because of so-called imitation and mirror neurons that in our brain, that they are mimic outside world very clearly. By Patricia Poole, demonstrated 11 months, baby can discriminate home language and foreign language. Neighbors come out and you listen to da 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 ta 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 da, then you can see the difference. So we pick up your French accent from your English very well. Yeah. Okay, so we can hear that. So we are very good at it. And this is another thing that's very interesting. That this one is by I think it's for the girl who did this study. I don't remember her name now. Yeah, but anyway, this is a kind of baby's cry. If I have to mimic to learn it, it's wow, 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 wow. So you heard the baby cry. Wow, 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 wow. That's baby cry. But for some linguists, like Bill Wang, they will pick it up and say, that is a German baby. That is a French baby. But if they are very good at it, they can hear it because the stretch is in the first syllable, not in the second. So it's a Ich eben Deutschland. Wow, wow. Wow, wow. Parlez-vous français? That's in the back. So in terms of a baby, you have to pick up not only your facial expression, but they heard this in terms of your intonation and where is the stretch. So the baby is very good at it. And so you can see our language capacity being built. And then the other thing that's coming out strongly with a lot of evidence is that in a random sequence of sounds, when they get repeated in pattern, the kids can learn pretty quickly that tuperos has been repeated, and they calculate it, and they associate this kind of high frequency sound to a certain outside stimuli. So the cue and repetition been paired up together. So very clearly that's a 8-month-old baby can do this. And that's the reason that we are able to sorting out or the care or the sound. We pick up similarity and the same pattern. And also, you can see people sound, if you say, well, I have two names. One is Kiki, the other one is Booba. Which one is Kiki? Which one is Booba? This one is Kiki. This one is Booba. And this is not only for Taiwan, because Taiwan, it happened to be this is Kiki, which have the all the angles in Taiwan in terms of Min dialect, Kiki. But in the language doesn't have this Kiki. They also use the same thing. A recent study done by Israeli scientists who are looking at the inventing of the language, you will see that they are using certain sounds, and then they are trying to portray a certain actions, and then ask the other people to switch the experiment, and they can really pick up certain sounds for certain actions. And so that's an interesting report being done these days. And then we have a language because of you are traveling to different places. Every place you change. Every place you change. And the most interesting case in Taiwan is in Taiwan, the Peking Mandarin has been changing a lot. So 我们说台湾国语 Taiwanese national language. You can pick it up. And so when you say 很好 very good 很好 in Taiwan nowadays, what you heard is 很好 很好 okay? 很好花花绿绿 you can say 花花绿绿花 is very difficult. Okay, so you change that you can changing, and so because of that, our language has been spread into from the root, and then a prototype, and then maybe to Pygmy, Nero, and then the African group, and then Indian, Arab, Iranian, Europe group, and this done by the linguist who's sorting this out, and clearly that gene has been spread into different world, but at the same time, language change in its diversity. Now, in terms of script, we also have the same thing. You can see 7 years ago. So you can have 7 years ago. And you can have who school. I don't know how to say it in Korean, but you can see. You can even use this Korean to express this same sound. But the most interesting case is in Taiwan, in Chinese. 福尔斯郭尔安德射文伊尔斯阿哥. Okay, it's not joking. Long time ago, when Taiwan is not as modern like today, we have a lot of singers in singing stars in Taiwan about 50 years ago, and they are singing English words, English song. They don't know English. They have to memorize them. So at one point, I look at one of their books, how they write down the song, the lyric, and I say, 我爷爷 我 is me 我爷爷是 grandfather. So I thought this singer is singing about her grandfather. It's not. It's 我爷爷. That's the way they do it. And it's not today. 3,000 years ago, the 越人歌壮族的越人歌 when they translate it into the Chinese sound, they actually take exactly the same thing, using the Chinese characters to represent the 壮族的声音, and then take thousands of years for people to figure out 越人歌到底在讲什么. Okay, so I won't have time to get into it, but that's another case of very interesting things. So after 1990, we have the so-called this particular functional image of this neural image. You can look at the visual. Where are they? Where are all these different places? We have MRI, and beginning with a PET that you scan them, and then resting time, and then in resting, what you can see, your eye open, the rest of them is rest, and then you can speaking to the subject, and subject lying down there, and when you speak to them, they pay attention, and their eyeball visual area kind of activated, attention area activated, however, and also their language area activated. Okay, it's kind of focal area been activated. Now you say, well, okay, I just ask you something. Now what I'm going to do is ask you to listen to music. So you said, so just the melody. And then you can see language disappear, except the right hemisphere activation. Okay? Now you said, put it together. It's too painful to remember where the way we were. Then you can see both of them come back. The whole brain is cooperating all the time. So you can see, begin to look into the brain, now we can actually see what's going on inside. And those are normal which is depressed patient. I won't get into that. Now we have a lot of tools, TMS, which can stop temporarily functioning of a certain area. And then eye tracking, ERP, auditory recognition, emotion, and some stop the some criminal that have been in jail. We did some study with them, and then asked them to stop. In certain cases, they have difficulty to stop, and you can see the spike in their brain. So you can do it, and you can see the MRI, you can see the MEG, and those machines are now all available for us to use. Expensive, but they are there. Interesting thing is this, we begin to able to do this analysis that by this group of people, they publish in Science, and you can see for the male and for the female, the male brain tend to be up in the same hemisphere connection, our male. But the female, from the very young, they begin to cross the corpus callosum using the both brain. It's very clear that men and women are different in terms of this connection. The way you can see, okay, a recent study that began to done by the MIT group of people, Ken Wisher and her group. You can see this is an auditory area for non-musical sounds, just pure acoustic. But then on the other side, you can see in the auditory area, you actually can have, what they did is that they get a lot of sounds, different sounds, 160 sounds. Each one of them is distinctive. For example, that you pop the beer, the red wine bottle. Or you can have a splash of the toilet, and all this different sounds, music, hip hop, and everything, jazz, and so on. And people can differentiate, they just listen to it. And then they get a scan. And after the scan, they do a very careful voxel by voxel analysis. Then they are able to break down into 6 different groups. 6 different groups around this area. Category 1, more acoustic, 2, 3, 4. All this previous 4 has nothing to do with speech and nothing to do with music. 5, this area is speech area. 6 is the music area. Very clear. In the past, we said language had to build up from something. Maybe music is one of them. But we could not find anywhere in terms of study. People search, and this group of people are so careful to get a lot of different stimuli come out, and then scan them, and then look at them carefully. And they finally discover a musical room in the brain. And that will make connection between music, speech, and the other acoustic sounds. And the speech and music are different, dissociated. And so that makes it very interesting for us to search for what happened in the beginning of this our species. The music is there, gesture probably there, timing, hook up these two, our language begin to start. So that's a story